Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for Exam FM on financial mathematics. Your company has just purchased a 3-year non-callable 5% coupon bond with maturity value of $1,000. Current spot rates for 1, 2, and 3 years are 4%, 4.5, and 5% respectively. Calculate this bond's Macaulay convexity based on its yield to maturity. So the price of the bond is calculated using the spot rates by discounting its cash flows. The cash flow of 50 in 1 year discounted at a spot rate of 4% corresponding to 1 year maturity or payment at time 1 year in the future, and cash flow of 50 time 2 is discounted at the spot rate for 2 years, which is 4.5%, and then cash flow of 50 of a coupon plus 1,000 of principal repayment, both at time 3 for a total of 1,050, discounted at the spot rate corresponding to time 3, which is 5%. And we calculate this to be 1,000.89. This indicates that in relation to the principal repayment at maturity of 1,000, the bond is selling at a slight premium, and the principal is also the amount on which the coupon is based. So the coupon yield rate is 5%, but the price is more than 1,000, indicating that the yield to maturity has to be less than 5%. Not that much, because the price is not that much above 1,000. And the yield to maturity is a solution of the equation that you see here, which simply takes all the cash flows and discounts all of them at one interest rate, that's that yield to maturity, and makes it equal to the current price of the bond, which is 1,000.89. Now, if you look at this equation, if you know the formula for a polynomial equation of degree 3, there is actually a formula. 100 years ago, students had to memorize it. Not anymore. You hopefully know the quadratic formula, but I doubt you know this one. But that's okay, because you can solve it using the financial calculator. In BA2 Plus Pro, you would enter 3 for n, negative 1,000.89 for present value, because the calculator treats everything as the setup as payment of a loan, and this is an asset, so it's like a negative loan. 50 payment and future value of 1,000, meaning that the loan is not repaid, that you have 1,000 at the end. And compute IY, and you will get about 4.9673%. Well, based on this yield to maturity, then the Macaulay convexity equals, for each time when a payment is made, you take the square of that time, so 1 squared times the present value of the payment, plus 2 squared times the present value of the payment at time 2, plus 3 squared times the present value of the payment at time 3, except you take the present value at the yield to maturity because the problem tells you to do so. That's a standard calculation of Macaulay convexity, so nothing unusual about it. And at the bottom, we simply have the present value, which we calculated to be 1,000.89. And we do this calculation, it comes out to be about 8.39-25712, which is answer E. This problem actually doesn't come from the Society of Actuaries. It's my own problem. I posted it as an exercise in 2005, but not on YouTube. And now I'm replacing basically that problem with this YouTube and DTube problem. It will be in both. So this is copyrighted material, and no reproduction is allowed without written consent from me, the author. Good luck in your studies, and good luck on the test.